Hello, welcome everyone. So, today we are going to start a very important chapter, and that is collision and conservation laws in that collision. Okay. So, collision experiments, why do we read that? The very basic thing is that whatever we know as of now, the world, the nuclear world, or many other kind of world, we could study them only because of the collision. So, collision acts as a kind of observation mechanism or tool for all of us. And the most important collision experiment till now which have gave the birth to nuclear physics is Rutherford scattering. Okay, so Rutherford scattering was groundbreaking experiment. So collision are of two type. One is elastic, another is inelastic. We all know it from class 12. Inelastic, you have your kinetic energy conserved, whereas in inelastic collision, your final kinetic energy is slightly lost in the form of heat. Okay, so this is what we have. So what we will study? We will study collision and center of mass coordinate. Okay, so they are that means the heading says that we will study collision in primarily center of mass coordinates. Like suppose that what is center of mass? If here it is mass m1, here it is mass m2, and if they are both equal, that is they are both equal to m, then exactly in between the center of mass will be there. Okay. So why do we do it in center of mass coordinates? The answer is very simple. Because the mathematics are simpler in center of mass coordinate system. And velocity of center of mass, we all know that it is sigma mi vi divided by sigma mi. Let me tell you what is the center of mass. Center of mass. So center of mass is something which is given by sigma mi ri by sigma mi. And when you differentiate this value, the center of mass, when you differentiate the center of mass, you get the velocity of center of mass. So suppose that the two particles are colliding. Suppose the two particles are colliding. The first particle we have here m1, the second particle is m2, and m1 is moving with speed v1 and m2 is moving with speed v2, and then they collide. Then we say that uh, velocity of center of mass would be simply m1 v1 plus m2 v2 divided by m1 plus m2. This is the case. So let me complete it here. M1 plus M2. And now we are required to understand the center of mass vector diagram. So here we have diagram, and let me tell you. So this point is mass M2, this point is mass M1, and if we draw the velocity coordinate, so this is V1 for M1 and this is V2 for M2. So how do we get it? Obviously you know the position R1 and R2, and once you know the position, that is R1 and R2, you can differentiate to get V1 and V2. Differentiate to get V1 and V2. And in between both the particle, what we will find? Center of mass. So this is center of mass. Okay. So now let us understand the vector diagram. So from here we can see that here is mass M1, here is mass M2, and here we have our origin. This is our origin at this point. This is our origin, this point. So you see M2 and M1 from origin. That is the rule of vector drawing. So if you see, if you stand from O and then you see at M2, so you will find R2. That is position vector of second mass M2. The same when you view M1 from standing on origin, it is R1. And then we know that what is the case for center of mass. Center of mass is the point which balances both the masses, and it is somewhere in between both. So suppose this is our center of mass. So let us draw the vector of center of mass. So this is center of mass. Now we are this origin. This origin is of lab frame. Origin is in lab frame, is in L frame. Now we want to move in from L frame to C frame, that is center of mass frame. Okay. So what do we do in C frame? So to move in, you will have to go and stand there. So now you arrived at this point, and from this point, you are going to observe whatever is happening. So from this point, you will first see M1. So you stand there and you see M1. So what you will do, you will draw vector from point of center of mass to M1. So this is one vector, and to view M2, you will have to do the same thing for M2. So now we have two different triangles. We name it triangle 1 and you name it triangle 2. So now the things are very simple. So now let us come to triangle 1 here. So when we will do vector addition, so what we will find? We will find that this vector, that is a vector of center of mass, a velocity of center of mass. So they are in the relation of triangle law of addition. What does triangle law of addition teaches us? So triangle law of addition says that if there is vector A like this and another vector B is on head of A, then what we could do? We could join them from tail to head, and we could get the sum of both the vectors. So the similar thing we could observe here in triangle 1 as well. In triangle 1, we could add velocity of center of mass plus velocity of first particle with center of mass is equal to velocity of first particle. And then you will get V1c is equal to V1 minus Vc. The same thing you could do for the second particle as well. And for the second particle, you will get, let me move it somewhere else. So this is for the first particle. For the second particle, we could say the same argument. And for second particle, we could say that V2c is equal to V2 minus Vc. Okay. So now there is one very important point to note here, that whatever I have highlighted right now, that is these two equations V1c and V2c, they are actually do have a mathematical relation as well. This was graphical relation from triangle law of addition. We have the pure mathematical relation which we will remember as well, and that is, let me write it here. It is a very important formula you need to remember, that velocity of any particle A with respect to B is simply velocity of A minus velocity of B. Okay, the same thing goes for position as well. Position of any particle A with respect to B is equal to position of A minus position of B. So this is same here. What we are doing? We are doing velocity of first particle with respect to center of mass is equal to velocity of first particle minus velocity of center of mass. Okay, so this is whole case. So let us move forward. We have understood this diagram. I am very confident because this is just a class 12 level thing. We were refreshing up. Now let us move forward. So from triangle law of velocity addition, what we did, V1c is equal to V1 minus Vc, and when you do the mathematics, you will find this value to be with you. Let us do it for the first particle only. So we need to find V1 minus Vc. So let us do it here. V1 minus Vc is equal to V1 minus Vc is nothing but M1 V1 plus M2 V2 divided by M1 plus M2. And when you solve that, you will get M1 V1 plus M2 V2 minus M1 V1 minus M2 V2 divided by M1 plus M2. Okay, and this is V1. Okay, and when you solve it, you will get that something is getting cancelled out. So M1 V1 plus and M1 V1 minus, they are cancelling out, and we are left with this relation. So let us simplify it. Okay, so how we will simplify it? We will take the common out. So we have common M2. So M2 will be out, and we will be left with V1 minus V2, and in denominator it will be M1 plus M2. So this is how we got this relation. In simple manner, you will put the value of Vc in this equation, and you will get it again. Okay. So you could pause the video and you could just think that what we have done. We have done just subtraction, nothing else. That is why I have written result everywhere, because we are in something that we cannot do each and everything in great detail. Now, you will have to notice that V1c and V2c are exactly in the opposite direction along the relative velocity vector. How? Let us see here. This is V1c is exactly opposite to V2c on the relative velocity vector. So what do we call, what is the relative velocity vector? Relative velocity vector V is simply V1 minus V2. This is again class 12 level concept. Okay, and they are all flowing from only two great concepts till now. Okay, the two great concept is the first one, triangle law of addition. The second one is position of A with respect to B is equal to position of A minus position of B. And if you differentiate it, you will get the velocity, acceleration, and so on in the same manner. And they all are interrelated, like they both are interrelated. Okay. The mathematical relation is actually the manifestation of triangle law of addition. So we have two important results here, that is of V1c here, and that is of V2c. So they are in opposite direction. Okay. Now we need to find one important thing, that is momentum in C system, center of mass system, and there has been one PYQ as well in this question. Okay, we will solve the PYQ in the separate lecture, but let me tell you, this particular concept has attracted one previous year question. So for mass 1, the momentum of the particle 1 in center of mass system would be the mass multiplied by velocity of the first particle in center of mass system. You can see that this is velocity of first particle in center of mass system. So we know that V1c from this equation. V1c is written here. So whenever you put the value, you get this value m1 multiplied by m2 divided by m1 plus m2. The similar thing when you will do for P2, let me write C here, P2C, that is momentum of second particle in center of mass system. How do we read it? If you don't know, let me tell you. This is momentum of second mass with respect to center of mass. Okay, so when you do that, you find this. So you know there is a striking similarity in these two. They are same but opposite in direction. Okay, and then there is another important part here. We are yet to mention that m1 multiplied by m2 divided by sum of m1 and m2 is one very important quantity, that is reduced mass. We call it reduced mass. So I think this is pretty clear. So now momentum of first particle in C system is mu v and momentum of second particle is minus mu v. So momentum of whole system would be simply zero when you add them, because they are same in magnitude but opposite in direction. So that means in center of mass system, momentum of system is zero. One very important lesson. Okay. And actually there has been one simple question from this, but if you don't know the concept, you will get confused. Now let us know momentum in lab system. Okay, L system. So in L system, the individual masses are m1 v1 plus m2 v2, but you could do it in the combined form as well. So you sum up the mass, but this time don't multiply with v1 or v2, but you multiply with the velocity of center of mass. So this is momentum in L system. So even if you know the velocity of center of mass, you could know the momentum in L system, because velocity of center of mass is actually determined by us and we are standing in laboratory. Okay, velocity of center of mass is taken from, is observed from, taken or observed from lab or L system. Because if I say you observe velocity of center of mass in C system, so mathematically you will write it like that: velocity of center of mass with respect to center of mass, and then this will be simply Vc minus Vc, and it is 0. So in argumentative form or in the mathematical form, we have derived the relation. And even in the funny way, let me say that you are someone who is center of mass. Now what is your velocity with respect to you? It is obviously 0. You are in the rest as per yourself. Okay, so that is the case with center of mass. Now what we need to do, we need to visualize the velocity vector, which is very important part here, because velocity vector must be visualized in two different scenarios. The first is before and second is after the collision. So we will do it in two systems. In the first time we will do it in L system, and then in second one we will do it in C system. So let us do it in L system at first. So we have two masses, mass m1, mass m2. They are going to collide in this region. In this region, they actually collided. And they moved on with deflection. Okay. So this part is before collision. Let me highlight it with a different color. This part was the case before collision. Now we have another part. This is after collision. Okay. This highlighted part is after collision. I am highlighting it so that it becomes graphical for you and easy to understand and remember. Okay. And now let me tell you one very important part here, that normal symbols are for before collision and primed symbols are for after collision. What is normal symbol? This is normal symbol. Okay. This V1 is normal system, but this is V1 prime. We read it as V1 prime. We call it V1 prime. So primed symbols are for after collision. That is the case for us as of now. Now let us move in the C system. So let me tell you, suppose our first mass is here, second mass is here, then in between we have center of mass. If it is here, then in between we have center of mass. Similar thing if it is here after the collision and the next one is here, then in between we have center of mass. So center of mass is something which is moving in this direction. Okay, so see, velocity of center of mass, it's something which is moving horizontally. Okay, vectors are such like such that, and so this is the case for before collision now. So what will happen? Velocity vector is in this direction. Okay, we have just translated, we have took this velocity v2 and we have put it here. Okay, we have took this velocity v1 in the same way without rotating or turning it, and we have put it here. And now we have applied triangle law of addition. So this point is your right now center of mass. This is center of mass. So from a center of mass, when you see the particle 2, you get velocity of second particle with respect to center of mass. And the same thing, when you do it in opposite direction, you will get velocity of first particle with respect to center of mass. Now, after collision, what will happen? The particles will move in this direction. This is the case for after collision. So what you do, you take this value and put it here, this vector and put it here. You take the another vector v2 and put it here, and then join them to get v1c prime and v2c prime. So let me tell you what is v1c prime. This is after collision. It is primed quantity, so it is after collision, and it is velocity of mass m1 with respect to c, that is center of mass. So this is how we read them. Notations are pretty simple. We are doing it from our class 11-12 days. Now real life experiment, let us go into the real life experiment, because ultimately we are learning each and everything so that we could apply it in real life scenario. Okay, like Rutherford did. So in many laboratory, okay, one particle, say M2, is at rest. Say Rutherford is scattering, that is gold foil is scattering. Gold foil nucleus was at rest and alpha particle was only moving. Okay, so in many scattering experiment, we do the same thing. So let us study this particular case. So let us calculate V1C at first. So V1 says what? Read it with me. V1 says velocity of M1 in C system, that is U stand at center of mass, and then observe what is happening. Then observe the happenings. Okay. So V1C is simply V1 minus Vc, and when you do it, you simply get M2 by M1 plus M2 multiplied by V1. For V2C, you will do V2 minus Vc, but this time V2 is 0 because our second particle is at rest. It is at rest and it is at rest, that means V2 is 0. So when you do V2 is 0, it is simply minus Vc, and this is the value. Okay. So it is pretty simple class 11-12 level thing, nothing much to worry. Just vectors and triangle of addition, and we all are done. So now let us relate L and C frame. How we will relate? Let us see that. This is now very important part, and this is again, this have inspired and attracted PYQs. Let me tell you, whatever we are studying it very precisely, so that we know that we are going to have our PYQs solved. Okay. So we have this mass M2 kept here, mass M1 here, but moving. This is at rest because velocity of V2 is 0 and velocity of V1 is V1. Okay. Now what you will do, you will study this all vector diagrams. We have vector diagram of C system before collision here. After collision, we have vector diagram here, and this is in the L system. So we will try to combine them in a single figure. So this is the case here. So what we have seen, let us see. This is velocity of center of mass in this direction. This is velocity of particle 1 with respect to center of mass. Okay, and this is velocity of particle 1 in lab frame, because we have no C here attached, but it is after collision because it is primed quantity. This is the primed quantity, but in center of mass frame. So we have combined that, and we have two different notations here. The first is theta 1. Okay, it is angle between B1 prime and BC, and this capital theta is angle between B1C prime and BC. Okay, so simple thing, they are both compared with VC, but they have the different they are different vectors. The first one is just v1 prime, that is velocity of 1 after collision in lab system. This is for lab system, L system or L frame, whatever you call it. This is the same thing but in C system. So you need to remember these two important part, and there is nothing to remember but to understand. Okay, these are fun part. So this is all about particle 1. This is all about particle 1, whatever I'm highlighting it. Now what about particle 2? So let us move for particle 2 as well. So this will be a diagram for particle 2. Okay, and where from where we have got this diagram? We have got this diagram from this part. Okay, so you need to understand this particular diagram to understand that. So what we have done here, that this is the capital theta here, and we have just displaced the vectors. So suppose that vectors are to be translated if you move vector from one particle, from one position to another, nothing will change. Nothing will change, because for vectors only two things matters. One is length and another is orientation. That is in which way it is pointing, because we know vectors are something which we have magnitude as well as direction. So length is for magnitude and orientation is for direction. So if you preserve the both and then you move it, it won't create any chaos. So what we did, let me tell you clearly. This is one vector, okay, and let us call it vector C. So what we did earlier, this vector C was here, or say here, okay, but now we moved it here just for comparison, just for completing the triangle. This is the triangle here, okay, because we need our answers from triangle of addition. And again, whenever you apply the triangle of addition, you get the velocity of second particle after collision in center of mass system. So this is the answer from this figure. I hope you are getting it. Now what we do, we consider that elastic collision is happening, or you can also call it a scattering, when mass m2 is at rest. M2 is at rest. Then you can call it a scattering as well, like Rutherford scattering experiment. Okay, so they are colliding, and they are colliding in elastic manner. That means kinetic energy is going to be conserved. Elastic collision means kinetic energy initial is equal to kinetic energy final. That is the case. M1 is moving with velocity v1, okay, and m2 is at rest. Now a scattering angle is this capital theta in center of mass system. We have described this angle already here. It is in center of mass system, that is particle 1 is scattered in this direction with respect to its initial direction, as simple as that. Okay, and also we know that velocity of center of mass is m1 v1, and here we would have m2 v2 as well, but v2 is 0, so this is not visible. Okay, so we are erasing it. We have left with m1 v1 divided by m1 plus m2. And we also know that velocity of first particle in C system is v1 minus vc. Velocity of second particle in C system is v2 minus c2. Fine. The thing we already know. These are velocities in center of mass before collision. How do we know it is before collision? Because we use primed quantities for after collision. Primed quantities for after collision notations. So I am telling you each and every detail without caring for the fact that we are preparing it for UPSC. No, let us do it in as raw manner as possible, like from zero to hero, that kind of thing. So now let us try to look at the figure after collision. So after collision in lab and in lab frame, okay. So we see that V1 will move in this direction and V2 will move in this direction, and there we will have two different angle along with the initial direction, that is theta 1 for V1 and theta 2 for V2. Okay, masses are obviously M1 and M2, we all know that. So that is the way scattering happened. And again, let us draw the same figure by combining some lab frame quantity and some center of mass frame quantity. So you will get this part. Now this part is very important because it is going to connect the lab frame, because these two quantities are from center of mass frame and this quantity is from lab frame. So these are going to be connected. How they are connected? So let us write. So this is our triangle. Okay. From this triangle we could get this relation. Now let me tell you how could you get this. This is exactly the class 11 introductory topic. Okay, you need not to worry about anything. These are all very easy. You may have forgotten it, but it is very easy. Let me tell you how. So this is velocity vector v, and this is for c. Let me write it clearly. Velocity of center of mass. I may have forgotten this small c, but it should be here. Okay, you should note it in your notes as well. Don't forget it. Whatever I am telling. This is the vector v1 prime, and prime means it is after collision. Okay, this is v1 c prime, and here we have v1c. So what you will do in such cases, you draw a perpendicular. So you draw on a perpendicular. This is theta 1. So now in the outer triangle, you apply tan theta 1 is equal to perpendicular by base. And perpendicular is nothing but, if this is capital theta, then it will be v1c prime. Okay, v1c prime sine theta. And this is perpendicular, and base would be bc plus v1c prime cos theta. So this is what we have written here. Okay, this is v1 c prime sine theta divided by, this is v plus v1 c prime cos theta. And again I have forgotten to write c here, so let us write c here. Okay, this is, there will be c everywhere. Okay, let me write it all at once. Yeah, till now it is fine. So this is the thing that you need to know, that we have simply applied whatever we do it in very basic class, that is class 11. Nothing new we are doing it here. We are just finding the clue, just trying to make the right angle triangle here, and then we are just writing perpendicular and base part. So till now I think I am doing good. So let us try to finalize some moment. And if scattering is elastic, so in elastic scattering, we should know that velocity of any particle before collision and after collision in center of mass system are same. Okay, we will see it in some time. Let me tell you again. In elastic scattering, whatever is the velocity of the particle just before the collision and just after the collision, they will be same, but not in lab frame, in the center of mass frame. And that is the beauty of center of mass frame, that it is making the mathematics really easy for you. Okay, so that is what we need to learn. Let me tell you how. So till now, you just need to note that this is going to be true. So what is it? Read it with me. This is velocity of first particle after collision in center of mass system. Okay. This is velocity of first particle before collision in center of mass system. So they are equal. Okay. So what you could do now, you would replace this v1 c prime, okay, with respect to v1 c. Clear? So this is the case. The magnitude is same. Direction would be different. Let me tell you. This is true only for magnitude and not for direction. This is the case. Then again, what you will do? You will just divide by v1c in numerator and denominator. Then v1c will be cancelled from numerator, and you will be left only with the sign capital theta, and here you will be left only with the sign vc by v1c plus cos theta. Now we are required to find vc by v1c. What is their relation? Are they related somewhere or not? So how we will find that? We will apply two important big Brahmastra tools. That is the savior in mechanics. The first one is conservation of energy, and second one is conservation of momentum. Okay, the first one is conservation of energy and second one is conservation of momentum. So let us apply. If you apply the conservation of energy, but in C system, because in C system our mathematics is easy. For elastic scattering, kinetic energy of initial system is equal to kinetic energy of final system. So for initial system, you have half m1 v1 c square plus half m2 v2 c square, that is half mv square for the respective velocities. And here we have half m1 v1 c prime square plus half m2 v2 c prime square. That is the case. Okay, before and after collision. And again, from conservation of momentum, we know that in C system, the complete momentum of the system is 0 before and after as well. Okay, for individual masses, there would have been some kind of momentum, but for the complete system, they are 0 because the system is isolated. A scattering or collision is isolated phenomena. There is no external application of any kind of force. So we are pretty sure with that. You should know it. And we have already done it as well. So we know that initial momentum in center of mass is equal to final momentum in center of mass system, and they are both equal to 0. So this is initial momentum in center of mass system. Okay. So what is initial momentum in center of mass system? Simply m1 v1 c and minus m2 v2. So why we are putting it minus here? Because we have already done known that momentum of first particle in center of mass system is mu v or whatever, and momentum of second particle in center of mass system is minus mu v, and mu is simply reduced mass. So they are equal but in opposite directions. So we could simply write that without any issue. If you have forgotten it, let me tell you, we have done it here. This part, momentum in C system. Okay, everything is clear from here. We have already derived it to be this and this, mu v and minus mu v, where nu is nothing but reduced mass. So let us come to our original problem. Okay, so when you do it for before system and after system, you have got these two important relations, and from these two relations you could eliminate v2c and v2c prime from the energy equation. In energy equation you have these things, something after the collision, that is v1c prime and v2c prime. I want to throw them out. So to throw them out, we will need these two relations. Okay, if you put v2c and v2c prime from here to here, then this will be eliminated. So we have just taken out v2c and v2c prime, and these are the values. And whenever you put that, you will directly find in the very simple manner that V1C is equal to V1C prime and V2C is equal to V2C prime. That is, initial and final velocities are equal in magnitude. Okay, in center of mass frame, not in the lab frame. Again, I am telling you, in the center of mass system. We have already written it here. That is, it is C. C means center of mass system. So let us write it as well. In center of mass system, during elastic collision, speed of particles before and after the collision remains same and only direction is changed. That is the big thing for us. Also, we have velocity of center of mass here, and we have no V2 term because particle 2 was at rest. Okay, V2 is 0 for us. And V1C is here. We have already done it. V2C is here. So whenever you do it, this all thing, I think this part V2C prime is not required here. This is required. And what you do, you take the VC and you divide it by V1C. Then you will immediately get M1 by M2. Immediately. Not a big deal. Everything will cancel it out and you will get M1 by M2. And then you can get your scattering relation from this. Okay, here we have this thing, that is Vc divided by V1c. It is going to be M1 by M2. Okay, so what you do, you just substitute M1 by M2 for V1, for V2, Vc divided by V1c. That's the case. Okay, and till now we have got this very important equation, and this is important because it can take us from the lab system to center of mass system or center of mass system to lab system. Okay, and we only need the masses of the system, nothing else. And theta 1 is nothing but angle between V1 prime and Vc. We already know it. So now we are required to perform some analysis of a scattering angle relation. Okay, this is the relation of a scattering angle. We call it a scattering relation. Okay, and this is PYQ. Let me tell you, this is PYQ. 3 questions minimum have been asked directly. Okay, and this is core topic. So they will definitely ask the PYQs, future questions from this. Now let me tell you, scattering angle in center of mass frame. A scattering angle in center of mass frame, could it assume any angle? They can take any value. And what is scattering angle in center of mass? It is capital theta, this value, not this value. Okay, this value. So they can assume any value. Okay, also if m1 is smaller, less than m2, then there is no restriction on value of theta 1. This is in lab frame. Okay, and this is in center of mass frame. We already have written that. So there is no restriction when the m1 is smaller than m2. But if m2 is smaller than m1, then theta has a maximum value. Okay, and it is pretty simple to find the maximum value. The derivative would be 0 at that point. Okay, so that is easy, but that is the case. And this maximum value corresponds to the situation when v1 is perpendicular to v1c prime. v1 prime is perpendicular to v1 c prime. Okay, and how do we compare m1 and m2? Because we are saying if m1 is smaller than m2, okay, or m2 is smaller than m1. So how do we compare it in another way? So we have already done it, the ratio of vc and v1c. Okay, so we know that, okay, theta has a maximum value when m2 is less than m1. So let us find that maximum value. So recall the scattering relation, that is tan theta 1 is equal to sine capital theta divided by ratio of the mass m1 and m2 plus cos capital theta. For maximum, we know that tan theta 1 should be 0 when we find the derivation. So we did find the derivation and we found that cos theta should be minus m2 by m1 if tan theta has to be maximum. So for tan theta 1, this value should be true, and we have done nothing but differentiation is done here. So in that way, if you put the value of cos theta in this value and sine theta in this value from this all part, because if you know cos theta, you can know the sine theta as well. How? Let me tell you. Cos square theta plus sine square theta is 1. You know cos theta, so sine theta would be 1 minus cos square theta by so under root. Okay, so that is the case. So we know that cos theta, that is minus m2 by m1. So if you do that, you get the theta 1 maximum by this relation, that is m2 divided by under root m1 square minus m2 square. So this all was very important part, and I would recommend you to be as slow as possible to complete all these things. Okay, these are very important, and I will also give you the supplementary material to complete this chapter, and the remaining part, if there is something, they will be covered in question and answer format. That is what we call SPYQ. But till now, our core topic is complete in collision and conservation laws. So let us meet in the next lecture.